on whether or not I'd label that big N or little n. So that's a qualitative variable, chicken dish, different categories, and it's ordinal because there's an order to them. You also have the choice of what type of sauce you can get. You get one free sauce. You can get the Magoo sauce or honey mustard or barbecue or ranch. Okay, so here we have the summary values, the frequencies from 200 transactions. It's a sample of 200 transactions. So that means 10 people, for example, got the snack size and Magoo sauce. 9 people, for example, got honey mustard sauce and the plate size. And we're going to look at solving probabilities. So first, this would be a 4x3 contingency table. 4 rows, 3 columns. Just to clarify that, 4x3 contingency table. And the preliminary work, in order to solve for those probabilities, is I'm going to need the counts, the marginal counts, or the totals. So I'm going to add another column and another row and add up all of these cells to get those totals. So again, I would do 10 plus 81 plus 29. That gives me 120. And then go down each column. 10 plus 4 plus 2 plus 14. That gives me the 30. And then when I add up the totals of those totals, so 30 plus 95 plus 75, I get 200. And 120 plus 43 plus 15 plus 22, I also get 200. And the problem even told me we sampled 200 transactions. So this number has to be 200. If you do the math right, you have to get the same as the total number of observations. Okay, and I would label that lowercase letter n because the problem explains it's a sample of his transactions. It's not all of them. So we're told lowercase letter n equals 200. All right, I think we're ready to tackle the first question. Part A, what is the probability that a randomly selected customer prefers the snack size? So I'm going to practice with some notation. I'll let A, event A, equal that they get the snack size. Then looking at the contingency table, here are all the people that got the snack size, this column. So the total of the snack size is this 30, but I need it to be a probability, so I have to divide by the number of people sampled. So the probability a customer prefers the snack size is 30 over 200. Okay, part B, what's the probability a randomly selected customer prefers the snack size again and the honey mustard sauce? So I already defined event A as the snack size. Now I'll define event B as getting honey mustard sauce. Now you could also define your events like HM for honey mustard sauce instead of defining it or labeling it as B. That's okay too, and maybe that's probably easier to help you keep track of what's what. But for this example, I just stuck with the standard notation of A, B, C, and so on. So this question, I'm finding the probability of A and B. It's an intersection problem. So in that table I just reviewed, we had different formulas for the intersection. But the way this data is organized in this table, it's even easier than that. I don't have to use those formulas because I can look clearly from the table. I see, that there were exactly 4 people who got the snack size and honey mustard sauce. So finding the probability of A and B in this contingency table is just doing 4 out of 200. 4 people got the snack size, got both snack and honey mustard out of the 200 people sampled. So 4 divided by 200 is that probability. Probability of A and B. See, it's much simpler than using those formulas, trying to figure out are the 2 events independent or dependent. It's just not necessary when the data is organized in this way. Let's look at part C. What's the probability they get the snack size again? honey mustard sauce again, but this time we want A or B, one or the other. We're interested in investigating the behavior of those people who like the snack size or they like the honey mustard sauce. It doesn't have to be both. So finding the probability of A or B means finding the probability of the union. Now for this, you should use the addition rule. The probability of A or B from the addition rule is the probability of A plus the probability of B minus the probability of A and B. So this one, I would tell you to use the addition rule. Use the formula. Okay, so the probability of A is the snack size. So we can see 30 people out of 200 get the snack size. The probability of B is getting honey mustard sauce. 43 people out of 200 like the honey mustard sauce. And then when I did that math, when I added up all these, because that's what 30 represents, adding up all these, and I added up all of these, so that's what 43 represents, notice I double counted this 4. That's why in the formula we have to subtract it once, because it was included twice. It should only be included once. So find the probability of A or B means that 30 out of 200 plus the 43 out of 200 minus 4 out of 200. And that gives us 69 out of 200. That's the probability of A or B. Part D, would having barbecue sauce, that event, and the other event having ranch sauce be mutually exclusive events or non-mutually exclusive events? So remember, mutually exclusive means that the two events have no outcomes in common. So if I look at the table, here's barbecue sauce, here's ranch sauce. There's nobody who gets both. You're only allowed one sauce for free when you go to Huey Magoo's. So in this data set, there's no observations that got both. So just to use the notation and figure out what I'm doing in this problem, I'll call C barbecue sauce, getting barbecue sauce, and I'll call event D getting ranch sauce. And I know based on the definition of mutually exclusiveness, those two events would be mutually exclusive if their intersection equals 0. And then I'd say, yes, they are mutually exclusive. The probability of C and D equals 0. There's nobody who can get both sauces. So if you look at honey mustard and plate size, those are not mutually exclusive. There were 9 people who got both. Okay, but if instead I had 0 people in the survey get both, then they would be mutually exclusive. There would have been a mutually exclusiveness between honey mustard and plate size. So it's all just looking at if the intersection is equal to 0. In this case it is. Back to barbecue and ranch, like the question asks. Yes, it is.